In this video, I'm going to show you how to perfectly design a 3-story residential building using the software ProtaStructure. But here is the thing, before we even start modeling, analyzing or designing, there is one critical stage every structural engineer must get right, which is the structural framing, also known as the general arrangement drawing. Structural framing is where we position every columns, beams and slab in a way that balances safety, economy and functionality. I will be showing you the governing principles in structural framing, which some of them are: limit your column spacing to 6 meters to avoid excessive moment on the beam and save cost, minimize point load acting on beams, and finally, keep your slab panel under 30 meters square area to prevent deflection. Structural framing is totally dependent on the engineer, but the engineer has to follow the governing principles while carrying out his structural framing, and those governing principles is what I'll be exposing in this video. Once we are through with the structural framing, our next video will be about modeling, followed by analysis, design, and finally we will detail this 3-story residential building.
The unique thing about this 3-story residential building is that it will be sitting on a beam raft foundation.
One promise I'm making to you is that by the end of this video, you'll be able to design a 3-story residential building of any kind on your own. Miracle Okeke. Welcome to SamGoz Engineering, and in this channel I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. This is the floor plan of the 3-story residential building. We will be carrying out its structural framing, and once I zoom out, you see this is the 3D view of the 3-story residential building, and this is also the 3D view. So this is the roof plan, and this is the front elevation, while this is the back elevation, and these are my side elevation, and this is my sectioning. So but in this video we will be carrying out the structural framing of this 3-story residential building. So first, once you get your architectural plan from your architect, the first thing to do, the number one thing to do, is to first of all copy it out. Yes, the first thing to do is to copy out this architectural plan. Reason is because you know that we'll be placing our columns, we'll be placing our beams, even our slab, and doing this column placement and everything, we'll be deleting some certain features in this building. For example, we'll be deleting the dimension, the furnitures, and everything. So we'll do copy this architectural plan out in case whenever we need to reference it at any point, we'll just easily access it. Yes, so the first thing I'll do is that I'll come and copy out this architectural plan. So once I've highlighted this, I'll do CO, enter. CO stands for copy. Then I'll copy this and I would like to place it at this point. So this is where I'm pressing it. So if you see I've copied it out, I'll click on escape. Then next thing after copying out your architectural plan is to study it. Yes, make sure you study architectural plan. Reason why we do study our architectural plan is to know what the building is used for and to know the features of the building. For example, is it a residential building or is it a commercial building? You know that a commercial building and residential building, they will not have the same loading when you are doing your design and analysis. Yes, so you know, is it a residential building or is it a commercial building? Even if it's a residential building, yes, you also check the residential building. Are we having any gym area? Because you know that if we have any gym area, the loading on that slab will be different, in the sense that gym equipments, they have high load, like they are heavy, they are all heavy equipment, and two, they will be contributing higher load on the slab. So the slab, the gym slab will not have the same loading with other slab. These are the things you study in your architectural plan, and also study whether your architectural plan has a basement, because if it has a basement, if we are carrying out our structural framing must be done on the ground floor plan, not on the basement plan. And if it has a basement, you should know that you'll be having concrete walls to retain the soil. So, and also you check whether there is an offset or any cantilever. On any cantilever. But if you check here, we are not seeing there's no cantilever in this building. Yes, so that means this floor plan is typical from the ground floor to the roof level. So that's what is meaning. Even if you check here, because this is the ground floor and this is the first floor to the third floor, so the floor plan is typical. These are part of the reason why we will study our architectural plan. And also in the case of studying this architectural plan, you will see that here that this place is the same with this. They are typical, they are exactly the same thing. So after studying your architectural plan, next thing to do is to delete the things that are not necessary to us as a structural engineer. Yes, not everything found on this drawing is necessary to us as a structural engineer. That's why we made a copy, so that we will delete things that are not necessary to us in this architectural plan, while the original plan will still have it. So coming over to this point, some architectural plan will be having all these furnitures, chair furnitures, kitchen furnitures. Those things are not necessary to us as a structural engineer. We won't be needing it. Even the grid line, the dimensioning, and all these things, they are not also necessary to us as a structural engineer. If we want to dimension anything, we will dimension it by ourselves. So right now, what I will do is that I will be highlighting everything that is not necessary to me as a structural engineer. For example, the grid line. For example, the dimensioning and others. So what I'll do is that I'll come over and I will highlight them, and also come and highlight this. Then I click on select similar. So once I click on select similar, I see everything has been selected. Even this, we have something selected here. So I'll come and deselect everything that I'm having here. So what I'll do is that to deselect it, I'll hold my shift key, then highlight it. So once I hold my shift key and highlight it, if you see, everything here has been deselected. So what I'll do now is that I'll come over to this point. Remember, I want to erase everything here. I want to erase everything that is not necessary to me as a structural engineer here. So I'll type E, enter. So this is what I'm having now. So if you can see, I'm not having a very clean drawing. Yes, I'm having a very clean drawing that I can easily work on. So after deleting everything that is not necessary to us as a structural engineer, next thing to do is to create two layers. Yes, create two layers. One is the column layer and the other one is the grid line layer. The reason why we are creating this layer is because we'll be importing these layers in AutoCAD in ProtaStructure. Yes, if you do not create them, you will not be able to import it in ProtaStructure, and to your work will not be easier in ProtaStructure. So for that reason, I will be creating grid line layer and I will be creating column layer. And once I go to AutoCAD, once I get to ProtaStructure, I will import those grid line and column layers and then easily model it in ProtaStructure. So I'll type layer. Yes, I'll type layer. Click on. I made a mistake. So I'll type layer, click on enter. So once I click on enter, this dialog box will appear. So I'll come over, look at this point, it's called new layer. So I'll click on it. Once I click on it, I'll now type column. Yes, I'll type column, but I want to use column Y. Column Y. Y stands for YouTube because this is a YouTube video. So I'll do column Y and I'll click on enter. Once I click on enter, I'll write the color to be, I like to have, I want to use this color, and I'll click on OK, and I'll like my line width to be 0.5 because this is column. So this is column. I'll like it to be visible. So I'll like my line width to be 0.5, and then I'll click on OK. So at this point, I'll create another layer. Remember, I'll say we'll be creating column layer and grid line layer. So I'll click on this new layer again, and then I'll create grid layer. So I'll type grid, but I want to use grid Y. Y stands for YouTube, and then I'll also click on enter. I'll leave it. I want to choose this color. I'll click on OK. Then I'll leave this. The line width should be this 0.00. Yeah, for grid line. Your line width should be the wrist line width. Yes, I'll click on OK. Then after creating these two layers, I'll come over to this point and then click on exit. So the first thing I want to do now is to create my axis, which is my grid line. So I'll come over to this point and locate the layer that I just created now for axis, for grid line, which is grid Y. I'll come and check for grid Y. So where is my grid Y? This is it. So I'll come and select it. Once I select it, remember, we want to create our grid line here. So we want to create our grid line. So I'll type L, enter. Once I type L, enter, I'll say from here to, okay, I'll turn on my auto key by clicking on Ctrl F8. My auto key will be turned on. So if you see now, it's already on. So I want to create a line from here to here. And also I will escape, L, enter. I also will have a line from here to here. Reason for this line is so that we'll be able to locate the center of this block wall. Yes, if you do not create this line, you'll not be able to locate the center of this block wall because our grid line should run across the center of this block wall. So after creating this line, I'll now do SL. I'll do SL. SL stands for construction line. Enter. So once I do SK, enter, I'll do V. V stands for vertical. Enter. Then I'll come over to this point. If you see, this is the center of this line. I'll press this thing here. I'll escape. I'll do SL again. Enter. And then do H. H stands for horizontal. Enter. Then I'll come over to this point and press it here. After doing this line and this line, they are no longer necessary to me. So I'll click E, enter, and then delete it. So this is what I'm having now. Look at this, is a construction line. So it's running throughout this whole AutoCAD interface. But after, I will show you how to trim it off. So right now, The next thing we will be doing is that we will place this grid line in anywhere we are having block wall. Yes, we will place it in all our block wall. This is our architectural plan. We will place this grid line along inside all our block wall. So what I'll do now is that I'll come over to this, click on it, then do CO. CO stands for copy, enter. Then I'll copy it from this point. Then anywhere I'm having block wall, I'll place it there. So I'll place it here. This is a vertical wall. This is a vertical wall. I'll also place it here. Anywhere that I'm having block wall, I'll place this grid line there. So I'll place it here. Let me check, am I through? I will not really place it here because this is 6 inches block wall, that is 150 millimeter block wall, but this is 250 millimeter, this is 225 millimeter block wall. So I'm not really place grid line here, so I will leave it. But after, don't worry, we will see how we'll go about it. I'll place a grid line here. I'll also, I think we are through for here. Then at this point I'll place a grid line at this point, and then at this point I'll place a grid line. I'll place a grid line at this point, and I'll also place a grid line. Just place grid line in all your walls. Yes, you must place it in all your walls. Then after, anyone that you don't need, you can delete it. Yeah, after anyone that you don't need, you can now delete it. But at first, place it in all your walls. So this one, I'll not place it here because this is a dot, and also this is 6 inches block wall, that is 150 millimeter block wall. So right now, I think I have placed grid line in all my walls. So I'll escape. Then I'll come and copy this horizontal grid line, do CO, enter, and still repeat the same process. So I'll copy it from this point, and I'll place my grid line at this point. I'll place another grid line at this point. I'll place another grid line at this point, and I'll also place another grid line at this point, and I'll also place another grid line at this point, and then finally I will also place at this point and also at this point. So let's check, have we placed grid line in all our horizontal walls? Yeah, I'll also place here. Then have we placed grid line in all our horizontal walls? Place it in all your walls. Then after, anyone that you don't need, you can now delete it. So I think that we have done justice to that. Okay, look at this, we have not placed here. Yeah, so right now I think we have done justice to that by placing grid line in all our walls. So I'll click on escape. Then I'll come over. This is an, as like I said before, this is a construction line. So I'll click on rectangle. You can just type REC, that's REC, like enter. Then I'll now do a rectangle around this my architectural plan. So I like to have a rectangle, right? This, once I have this, then what I'll do is I'll highlight this rectangle. Make sure you highlight the rectangle, because if you don't highlight the rectangle, maybe you delete from here to here, why you still be having this line continue from this side. Yeah, so make sure you highlight the rectangle, then type TR. TR stands for trim. I'll click on enter. So I'll come trim of this, I'll come trim of this, trim of this, and trim of this. So if you zoom out, you see those construction line is nowhere to be found again. I'll escape. Then I'll now highlight this, click on E, enter. So this is what I am having now. If you can see, I've successfully placed my grid line. So next thing that I'll be doing now is my column placement. For me to start placing my column, I'll also come over to this my layer and select my column layer, which is column Y. So I'll just come over here and locate C. So locate C to select my column layer, which is column Y. This is it. So I'll come and select it. So once I've selected my column layer, then I'll come over. Remember, I would like to be using the column size of 225 by 225 because the block wall they are using here is 225 by 225. Let's click on this. We are having from this point to this point. Look at this, it's 225 by 225. And I also right click again. We're having from this point to this point. So if you see, our block wall is 225 by 225. So in this case, I will be using the column size of 225 by 225. And if you have 225 by 225 is the minimum column size that you'll be using. Yes, but you know, this is a 3-story residential building. So there's a possibility that 225 by 225 block wall will fail. But if it fails, then we will not increase the size of that section that failed. But that will be in ProtaStructure. So that is why you need to follow this video till the end. So you get to learn everything concerning residential building design. So I'll come over to this point and then type on rectangle, enter. Make sure that you use rectangle, because if you use normal line, ProtaStructure will not recognize normal line as your column member. So you either use rectangle or you use polyline. Yes, because these are the two lines that ProtaStructure will recognize. But for normal line, ProtaStructure will never recognize it as your column. So make sure you use rectangle or polyline. So I will now type. I'll first of all click here. Then I'm using column size of 225 by 225. So first of all, you type at. You must put at 225, comma, then 225. Then you now click on enter. So this is my column. Yeah. So since I've gotten this, let me also say something. column placement is solely dependent on the engineer. Yes, my column placement can differ from your column placement. Yes, but the thing is that the engineer needs to follow the governing principles in column placement in order to place his column well. Because once it comes to structural design, two things are of necessity to us. First, safety. Second, economy. If your building is safe but it is not economical, you are not a good structural engineer. But safety is our priority. One thing with all these builders and masons that we are seeing out there is that let's say that they prioritize safety, but they don't have any idea of economy. That's why if you come to their building, you'll be seeing cone all around. They'll scatter cone around this whole building, and which will not make the cost of the building to be high. That means they are not economical in their design. That is why we are better than them, because we are engineers. We have been educated that economy is also part of the things we need to consider once it comes to structural design. So I'll copy this thing and see, enter. If you are placing your column, make sure you place them at anywhere you're having wall intersection, or make sure you place them at any point you're having wall intersection, and to make sure that your column is inside your block wall. For example, don't place column in any of your window. Yes, I forgot to mention something. If you are deleting the things that are not necessary to us as a structural engineer, please don't delete your windows and your doors. Yes, because if you delete your windows and your doors, you might mistakenly come to this point and place a column, not knowing that this is a window position. So once you are deleting things that are not necessary to you as a structural engineer, please don't delete your windows and also don't delete your doors, because you might, for example, there are some buildings that have done their design at the edge here. Yeah, at the edge here, they will be having windows at the edge here. Yeah, this is the architect might decide to put a window here. But if you delete your windows and your doors at first, that means you might mistakenly come and place a column here, so which is not proper. So first, don't delete your column. So I'll be placing my column members. And also another governing principle in column placement is that your column spacing should not be more than 6 meters. Yes, it should not be more than 6 meters. For example, from here to here should not be more than 6 meters. Reason is because you know that from here to here, it is let me escape. Reason, from this point to this point, it is a beam that is connecting these two things. Yes, it is a beam. And if your column spacing is more than 6 meters, that means the load coming to that beam will be high. Remember, the formula for simply supported beam the formula for maximum moment in a simply supported beam is WL square over 8. Yes, if you can see, we're having WL square. You see, L is squared. That is, the length is squared. That means the more the length, the more the moment. And the more the moment, the more the reinforcement that you are going to provide to counter that moment, or the more the bars you are going to provide to counter that moment. And the more you are providing these bars or increasing the beam depth, you are no longer being economical in your design again. So make sure that, but this is only applicable to solid slab. You know, we have different type of slab. We have solid slab, we have waffle slab, we even have flat slab, and many even hollow coil slab. Yes, but this is only applicable to solid slab. Yes, it is not applicable to flat slab, and it's also applicable to waffle or lip slab. So make sure you limit them to 6 meters to avoid high moments on your beam. But don't worry, we'll still explain this thing more during our structural framing during the course of this video. So I'll place here. After, I will now start checking whether it is less than 6 meters or is it more than 6 meters. So, but let me just place column at the points I believe that I should have column. But I will not place any column here for now. If you see, this side is setting as this. So after placing column here, I will not mirror it to this side. Yes, after placing at this point, I will not mirror it to this point because they are typical. Then I would also like to place a column here. Don't worry. Hey, we will not place a grid line here. We will not place a grid line here. So let me. I will just escape. We not. Oh, okay. Sorry. You place. Look at. I'll place a column here instead of placing here. I'll not place a column here. So let me go and copy my column again. I'll click on C. Enter. Don't forget, please, if you can get the CAD file of this architectural plan and practice on your own. Yes, it is very important. It is very important. You can get the CAD file. The CAD file comes with the structural detailing. Yeah, look at it. The structural detailing has already been done. For example, look at these are column detail. These are first floor beam and column layouts. These are foundation detail. So the detailing has already been done. So if you get the CAD file comes with the architectural plan and also comes with the structural detailing. Yeah, in case after your modeling, analysis, and design, and you enter the detailing, in case you need to reference anything, in case, for example, you don't know how to section your slab, look at it, it's already here. You can easily reference it and section your slab. But don't worry, we'll also be doing the structural detailing of this 3-story residential building during the course of this video, so you don't need to worry about, but just get the architectural plan at least to support the channel and also to practice and develop yourself, because practice makes perfect. Yes, the more you practice, the more you get to learn it, and the more it gets to become part of you. So you can get the CAD file, and to don't also forget, you can also share this video in your class group or anywhere, so that more people will get to learn, not just only you. So I'll place a column here. Then after, I'll now start checking, is it more than 6 meters or is it not more than 6 meters? So I would also like to have a column placed at this point and a column placed at this point here, at this point and at this point. So coming over to this point, I would like a column placed at this point. Yes, and I will also like a column placed, right? Is either I place a column here or I place a column here. But don't worry, after I'll come and explain something around this area. Yeah. Then I would also like to have a column placed. I would like to have a column placed here. Yes, don't worry. After we'll still explain more on this. I like to have a column placed at this point, and I also like to have a column placed at this point and also at this point. I'll come now and come and start checking my column placement to know whether it is less than 6 meters. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside you. So in checking whether your beam placement is less than 6 meters, I'll come and click on my dimension. So I'll check what is distance from here to here. I'm having it to be 3.225. I'll also click here, check what is distance from this point to this point. Yes, I'm having it to be 2.025. So if you can see, this is less than 6 meters and also this is less than 6 meters. That means it's okay. But I'll come and still check on one thing. What is distance from this point to this point? So look at it. I'm having 5.25. Yes, 5.25 meters. Remember what I said? Once it's less than 6 meters, yes, a beam can run once it's less than 6 meters. Because of one, our priority is safety. Then after safety, you see economy. So having a column here, a column here, a column here, yes, the structure will be stable. Safety is in view. But also having a column here, here, and here, economy is no longer in view, but safety is in view. But our aim is to make sure that economy is in view and safety is in view. So for that reason, I'll be removing this column. Also, another reason why I'll remove this column is because we are having slab here. Yes, so there will be load coming from this slab to this beam. This slab will transfer its load to this beam. So, and there is no slab here. So if you can see, this beam now will carry only load coming from this slab. So that means there is no much load coming to this beam. So these two reasons, there is no need why I will have this thing here, because of safety, because of economy. So, but you should know that after design, there is probability that we might be having here to be 3y16. That's the bottom bar, 3y16, or maybe let me say at the end, maybe at the center. Don't worry, I will see explain it later, but let me just explain what I want to explain now. Maybe after now, we'll be having here to be 3y16. That's after we have removed this. Yes, we'll be having to be 3y16, maybe. So, you know, most of the clients, they don't really like when they are seeing 3y16 in their work. They will tell you that I did this project here, you know, they use 2y16 or throughout. Why is it that your own, I'm seeing 3y16? Are you sure you know what you are doing? You have to explain to them. Maybe the person that did the work is all these artisan on site. You know, once, if he's an amateur engineer, he will place column at all round. He will place column here, he will place column here, and he will place column here. And if you place column here, let me tell you, you must, if you place a column here, that means this beam must surely be under 2y16, is a must. But the thing is that it will be under 2y16, but economy is no longer in view, because if I remove this column and have 3y16, I'm still making profit. Like I'm still having economy in view, because I will just, because you know this column now consists of 4y16 and your concrete. Yeah, but if I'm able to remove this and just have only 3y16, that means I did a good job. So these are the things you have to explain to the client, so he will not take you as do I say casual or just somebody that doesn't know what he or she is doing, because you know that they lack knowledge. Yeah, so you have to give them the proper information that they need to work with. So if you just explain this, like if you finish explaining this now to them, you see that next time they will call you, because they have seen that you know what you are doing. It's not that you know that you are doing guesswork, but you know what you are doing actually. So I'll just click on E, enter to delete this, because this is still less than 6 meters and it's carrying the load coming from this slab alone. So I'll also come and check for this side. I'll click on my dimension. I'll check distance from this point to this point. So I'm having it to be 3.45. So it's okay for me. Then I'll also right click again. I'll check what is distance from this point to, okay, let me check this point to this point. Then I'm having 1.4. Is okay. It's less than 6 meters. Then from here to here, I'm having 2.4. So that means the total, let me check the total. let me check the total. The total from this point to this point, I'm having it to be 3.825. So if you see, this is less than 6 meters. But for me here, I'll leave this column here. Yes, I'll leave this column. I'll tell the reason why I chose to leave this column. But I say structural framing is totally dependent on the engineer. Another engineer might decide to remove this column. But for me, I want to leave this column. Reason is because this now is a joint. Yeah, this is a joint. Look at this is an intersection between this wall and this wall. And if you see, this is a very long wall. Yes, this is a very long wall. This is not a short wall. If you see, it's 3.45. So if this wall come and intersect with this, if I leave it like this, maybe in future or thereabout, there might be crack. I do not say there will be crack. I say there might be crack. So for that reason, I would like to have this column here, and also this is an outer joint in the sense that this is our surrounding, and this is our this is the outside. That's the surrounding, the environment. Why this is the bedroom, yeah, inside the building. So for that reason, I would like to leave this column here. But another engineer can decide to remove it. It will still work. Also, another reason why I would like to leave this column here is because this beam now, this beam will share its load between this column and will share its column between this column or this beam and this column. You understand? That's this beam now. It will share the load that is getting from this slab between this column and this column. That means if I leave this in here, there will be a point load here, but that's not a very strong reason. But I just want to leave this in here because of this is an intersection and is also an outer intersection because this is the surrounding and this is the inside. So I'll leave this column here. Then I'll right click again, click on my linear. I'll shake from this point to this point. Sorry, I made a mistake. I'll right click on my linear. I'll shake from this point to this point. I'm having 3.8. I'll also click on my linear again, shake from here to here. So if you see, that means a beam should be able to run through. Yes, I'm having 5.4. So for me, I'll remove this column. Yes, I'll remove this column based on the things I explained here. But let me explain it one more time so you understand. First reason is that this column now is carrying just the road coming from this slab. There's no slab here, so it is not carrying any road from this slab. It's carrying only the road from this slab. So for that reason, is not carrying much load is not coming to this beam. Also, another reason why I remove this beam is because this is less than 6 meters. Look at it, it's 5.4. So first, it's carrying a lesser load and it is less than 6 meters. Don't forget what I explained there. Maybe after design now, I'll be having 3Y16 here. If you have 3Y16, it's okay. Yeah, it's still okay. Maybe your client might have done works or projects that all through it is 2y16. You should be able to explain as an engineer. Maybe in the one that he carried out, the project that he carried out, he has a column here and also here, because if you have column this point, there will be high probability that you'll be having 2y16. Yes, there is high probability that it won't be 3y16. But if I'm having 5.4, there is high probability that I'm be having 3y16 here. So explain to that to that client that you are trying to save cost. That's why you remove this column and then replace it with 3y16 instead of 2y16. If you check the cost, because column consists of 4y16 and concrete. Yes, if you check the cost, you see that he is making profit, but he doesn't know that he's making profit. He thinks that he's making a loss. Yeah, because what client, even if you place 40 columns here, they will not ask you any question about it. But once you start having 3y16 in your beam, they will start thinking, hey, this guy doesn't know what he's doing. But if you have column at every joint, they will not consider it as anything. That's just the thing. So you have to explain to them. So for that reason, I will remove this. Let me escape. I will remove this. Enter. I'll delete it. Then I'll be having my beam. I'll be having my beam long like this, and then a beam will also, and unless this beam now will run and rest on this beam, because a beam will run from here to here, so this beam will run and rest on it. So that's how it will be. So I'll come over to this point. This one definitely it should be okay. I'll click on my dimension and check what is done from this point to this point. So I'm having 3.97, so it's okay, it's less than 6 meters. So I'll also come and check this top one. I'll right click on linear, I'll check from here to here. So I'm having 3.825 is okay. So I'll also check from this point to this point. So if you check now, if you do this plus this, is less than 6 meters, but I'll leave this column here and also leave this column here. Reason is because there is no, here is a void, this is a void. That's the reason why I'm leaving this column here and here. Assuming right now I'm having a beam running through, I will remove this column. You understand? Assuming I'm having a beam running through, I'll remove this column. But since here is a void, look at where our beam is. This is where our beam should be. Yeah, we should place our beam here. Since here is a void, I'll leave this column here. I'll leave this column here because I would like the column to be at this wall intersection and also at this wall intersection. But if I had a beam running through, I'll remove this column to save cost. So I'll leave this column here. So I'll right click again for my linear and check distance from here to, let me just check straight. So I'm having this to be 5.55. I will remove this column because first, it is less than 6 meters. Second, it's carrying the load just from this slab. There's no slab here. There's no slab here. It's carrying only load from this slab. So it is less than 6 meters and it's carrying load from this slab. So for that reason, I will remove this column. Don't forget again, if you remove this column in your design, you might be having 3y16. Leave it, is okay. If the client should complain that he's having 3y16 but other project is 2y16, explain to him. He doesn't know. He doesn't know. Most of those projects, maybe they're having column here and having column here and also have column here. If you have column here, here and here, your work must be 2y16 is a must. But if you remove this, that means the probability of you having 3y16 have increased. Yeah, here might be 3y16, but even though it is 3y16, you are still saving cost. You are still economical in your design because the cost of this column now, this is 4y16 and a concrete. But if you remove it and just replace it to just one bar of y16 of 5.5 meter length, that means you save cost. But the client doesn't know because all the work they have done is that maybe they will have column placed at all, maybe they will have column here, maybe they will have column here, here, and also in this case they'll have column here, here, and here. They'll come and have column here, here. They'll have column placed all around the building. Then they'll think it's normal, but they don't know. And two, the more you are placing column, the more you are having 2y16, 2y16. So that's what they don't know, but you have to educate them so that they will know. So at this point, I'll come and shake here now. If you see here should be if you check I should have a column along here. Yes, so I'll copy one of this column. I'll copy this column and do enter. I'll copy it and I'll place my column at this point. Yes, I'll place my column at this point and then I'll come and check my dimension again. I'll check from this point. No, I'll right click. I'll check from this point to this point. What am I having? Oh, I made a mistake. Okay, yeah, I'm having 5.25. Okay, I'll also check again from this point to this point. Sorry, let me just escape. Let me right click again. That's to repeat linear. I'll do from this point to this point. So I'm having it to be 4.125. So if you see this beam here, this column here is okay. I don't need another column. But if it's all this artisan on side, they'll place a column here, they'll place a column here, and then here. They'll be having 4 columns here. But me, I have only 3. 1, 2, 3. And since I have placed 3, the probability of me having 3y16 is high. Yes, but if you are placing, assume I remove this column now, assume I removed it, enter, and then copy this one. Let me say I went with this. Assume I remove that column and I'm having something of this nature. I placed a column here and I placed a column here. Yes, that means the probability of me having 2y, that means I'll be having 2y16. Yeah, I'll be having 2y16 here, 2y16 here, and 2y16 here, which is normal. But since I've removed this 2 column and just replace it only one here, that means I might have 3y16. Do you understand? Let me do Ctrl Z, and also Ctrl Z, Ctrl Z. So I'll have this column here. And also the reason why I left this side is because this is a void, this is a staircase. So that means this is a void. This beam is carrying load from this side alone. And so for that reason, I've done my column placement. I hope you understood the principles I explained and things that I explained. So I'll click on this, click on select mirror, and then do enter to erase all of them. Then right now what I'll be doing is my paneling and beam placement. Once it comes to paneling, the thing you should know is that your panel should not be more than 30 meters square area. As your panel is slab, it should not be more than 30 meters square area. For example, let's check. We are check from this point. We check what is the from here to here. I'm having it to be 3.825. I'll right click again. I'll do from here to, okay, we see that this, I'm having to be 5.25. So if you see this one, if you do 5 times 5, 5 times 5 is 25, but I'm having 3 here. So that means this is not up to 30 meters square area. So that means I'm okay to call here my panel. But if this panel is more than 30 meters square area, there are 2 things that you can do. Is either you increase your slab depth, that's you might move from 150 to 175, or you introduce a beam. Introduce a beam here to demarcate this. So here will be one panel and here will be one panel. So it's either you increase your slab depth or you introduce a beam to cut this slab. Maybe you introduce a beam here and a beam here. So you divide this slab. Here will not be one panel and here will be one panel. But note that this slab area should not be more than 30 meters square area. It's only applicable to solid slab. Yes, it is not applicable to waffle. It is not applicable to flat slab. It's not applicable to rib slab. It's not also applicable to hollow coil slab. It's just only applicable to solid slab. So these are the things you should know. So since I've said that the whole of here should be one panel, I'll delete all these things. Yes, I'll delete all of them. I'll delete all of them. because I want to have here as one panel. I'll also delete the whole of this. Yes, I will do okay. I'll also come here over here and delete this and then do E, enter. So this is what I'm having now. Then what I'll do now is I'll come over to this point, click on this ES, enter. ES stands to extend. I will extend this and I'll also extend this. ES is for extend. I will extend this and I'll also extend this. So this is what I'm having. I'll also come over to this point. I'll click everything, do ES, enter. So I'll come and extend this and also extend this. Yes, so I'll delete this. I don't need this. So this is now one panel. Hope you understood. So I'll click on this and I'll check from this point. I want the whole of here, both this bathroom and toilet and bathroom, to be under one panel. So I'll, so if you see, as me is all these people that don't know anything about structural design, they will place a column here because they are seeing wall here. They will place a column here and also come and place a column here. And if you are placing a column here, placing a column here, you'll be having 2y16. Yes, but since I've decided to have here as one beam, the whole of this length as one beam, that means it is not. That means you'll not be having that means the probability of you having 3y16 has increased. Yes, but don't forget, it should not be more than 6 meters. So, because once it's more than 6 meters, if the moment is very high, it might require you to increase your beam depth, or you might not be entering into y20. Do you understand? So just limit it to 6 meters. Yes, limit to 6 meters. So I will right click again, click on my linear that's dimension, and check what is that from here to here. I'm having 5.4 and 3.6. So as me, I'm 30 is 6 times 6. So this is not up to 6, this is not up to 6. That means it's not up to 30 meters square area. So I'll click the enter and then I'll convert the whole of here to be one panel. So I'll do the whole of here to be I want to have the whole of here. I want to have the whole of this to be one panel. E, enter. Then I'll also come over to this point and then click on this and also these two things and then these two. E, enter. So I want to have everything as one panel. So I'll come over here and select this. ES, enter. I will extend. I will also extend. I will also extend. I will also extend. Then I will escape. Then I don't really need this. I don't really need all this. Yes, I don't need them. So I'll click on E, enter. Then I will come and click on this, do ES. ES stands for extend. I will extend this and I will also extend this. I will then escape. So this is one panel, this is one panel. Then coming over to this point now, I want to make this sitting room one panel, and then this veranda and this toilet and bathroom and this toilet one panel. So I'll come and check what is my dimension to be sure it's no more than 30 meters square area. So I'll come and check from here to here. I'm having 4.23. This thing should be 4 point, maybe 25. I don't click it very well. I don't get the edges very well. Okay, look at it. I don't really get it well. So I'll shift from this point to this point. I'm having 3.79. Look at, I don't get it well. That's why it's 3.79. So, but if you check, both of them is not up to 30 meters square area. They are not up to 6. That means they are not up to 30 meters square area. So I'll have the whole of here as one panel. So I'll delete this. I'll also come and delete all this. And I'll also come and delete this. And I'll also come like this. And then delete this. And yes, I've deleted this. I was, I remember I said that here will be one panel. So I also like to delete these ones too. I'll also come and delete this. And I'll come over to this point and then delete this. I will then hold my shift key to deselect this, click on E, enter. So this is what I'm having now. Then I'll come over and select this, click on ES, enter. I'll extend this line and I'll also extend this line. Then I'll escape. Then I'll come over to this point. Then come over and click this and do ES, enter. I'll extend this and I'll also extend this. Then I'll come and click on this. Yes, I'll come and click on this, do ES, enter. I'll extend this and I'll also extend this. Yes, then I'll come over, okay, and I'll come and extend this one. Yes, then I'll escape and then come click on this, ES, enter. Then I'll extend this and I'll extend this, and also I'll extend this and I'll extend. Okay, this line not extend to this place, so I'll just come and delete all these things here. Yes, and also delete this door and window. Sorry, this, because it's not needed. I'll delete it, E, enter. Then I will click on this, do ES, enter, and then extend this line. So this is what I'm having now. So this is one panel and this is one panel. I don't really need this staircase. I don't need it. I'll delete it. So coming over to this point, I'll like to make the whole of here one panel. But let's check the dimension. Let's be sure there is no more than 30 meters square area. For then from here to here, I'm having 5.5. Then I'll click on linear again. From this point, let's check from this point to this point. I'm having 3.25. So this one, none of them is up to 6 meters. It's not up to 6 meters. It's not up to 6 meters. That means it's not up to 30 meters square area. So I'll click on E, enter, delete this. That means I will have the whole of here to be myself. I thought we agreed that we should delete this column. Maybe I forgot to delete it. We agreed that we'll delete this column, that this is not up to 6 meters and is carrying load just from this slab. So we agreed that we'll delete this column. Maybe I made a mistake and not delete it. Yeah, I've deleted it now. So I'll also come and click on this and do E, enter. So this is what I'm having. The whole of here will be one panel. So I will right click and do E, enter. So I will now do, I will come here, I'll highlight this, do ESC, enter. I will extend this and I will also extend this, and I will come and extend this and extend this. Then I'll also come here, I'll come over to this point, delete something, delete this is not needed, and I'll also come and delete this, E, enter. Yes, and I'll highlight on this to extend this line. I'll do ESC, enter. Then this, yes, and then I'll come and extend this and also come and extend this. So this is what I'm having now. So that means here is one panel, here will now be one panel, and here will now be one panel. That means I'll just come and delete this because I don't need this again, and also I don't also need this. Enter. Then I'll do ESC, enter. Then I'll extend this and I'll extend this. So this is what I'm having now. Let me trim off this TR, enter. So I'll do, sorry, TR, enter. So I'll trim off this and I'll also trim off this. So okay, let me leave this trimming because this is not what we are here for. So I'll leave this. So if you can see, I've successfully paneled this, enter. I've successfully done my paneling, both my column placement, beam placement, and also slab placement. So this is what I'm having right now. So what I'll do now is that since here and this side they are the same thing, I'll mirror this to this side because here and here they are all the same thing. Hey, look at what we're having here. I want to explain something here. So if let me click on my dimension. Let's check the dimension that from this point to this point. We're having it to be 2.2. 2.025. Then I want to check from this point. Don't worry, I want to explain something so you understand something. I want to check from this point to this point. I'm having it to be 4.125. Yes, I will also right click again. I will still explain what I'm doing so you understand. Check distance from here to here. So I'm having it to be 4.35. Okay, yes. So right now I want to move this column from here to this point. I will explain. I want to move this column from this point to this point. Look at the reasons why I want to move this column. You know that this beam now is 4.125. Yes, but this beam now is carrying 2-point load. Two, not just one, it's carrying 2-point load. That's the load from this beam and also the load from this beam. So this beam now is carrying its load. Like the slab load is transferred to this beam. Then this beam will now divide it into two. It transfers some to this column and then transfers some to this beam. So this beam now is a point load to this beam, and also this beam is also carrying a point load from this. But if I should move this column to this point now, even though the adherents have increased to 3.25, it will now be carrying only 1-point load. So me, I'll prefer to move this beam to this point because I believe that if I move this beam to this point, that means the load on this column, like the load will be somehow even. Because if you leave this thing like this, the load coming to this structure now, the load coming to this beam now is too high. It's too much. It's too much. But if I should move it, let me do enter. Let me move it so you understand what I'm saying. And place it at this point. Yes, even though this beam now will not be carrying only 1-point load. Yes, only 1-point load. That's this point load. Even though it's 4.35, it will not be carrying only 1-point load. And also the load. Remember, this slab will share its load between this beam, this beam, this beam, and this beam. And then this one will also share its load between this whole beam, this beam, this beam, and this beam. So after sharing, this one will share its beam. Then this beam, after this slab, this slab will share its beam between this and this. So this beam now will not share its load between this and this. That means it's half of the load that is coming to this beam. I don't know they understand it, but here this beam now is too long, so the load coming from this will be more than the load coming from this, even though they are in two directions. But this one is a very long beam, and this is a very big slab panel. So I don't know whether you understand what I'm explaining, but I just trying to explain about moments, because I know that if I should leave this column here and allow this beam to run like this is a point load, this is a point load, I'll be having high moments on this beam. But if I should bring that column to this point, even though this is a slab, this is a slab, at least the point load have reduced, and also the load coming from this slab now is no longer that much because this is a beam. So the load is just from this small slab, and also from this portion like this, from this portion like this rectangular, yeah, that will be coming to this. So for me, I just prefer it like this. But I don't really understand. I don't really know whether you understood what I explained, but I believe that you understood. So right now I want to mirror. So for me to mirror, I will delete everything here and then mirror this. So I'll come and delete this. I'll delete everything here. I'll click on E, enter. So after I've deleted everything here, let me also delete this dimension because I don't need them. Let me just click on select similar and then do E, enter. Then I'll now come, okay, before I'll do it, I have to locate my base point, which should be here. I'll click on L, enter. So here, from here to here should be my base point. Remember, look at this whole building. Remember I told you it's symmetrical. So the center of this whole line should be within this staircase. It should be the center of this staircase. So look at it. So this thing I did now, I'll be able to locate the center of this staircase using this line. So I'll just come over to this point and then highlight this, do MI, which stands for mirror, enter. Then I'll specify my base point. So I'll turn on my auto key by clicking on Control F8. I'll turn on my auto key, then I'll press it here and then click on no, that I don't want them to erase the main of the erase the source. So I'm having this now. Then I want to ES, which stands for extend. I'll extend this line and also extend this line. Come over to this point, I'll extend this line and extend this line. So I'm through with my paneling. So this is how my beam will run, and I hope you understood everything I did now. So I'll come and delete this. So the next thing that I will do now is what is called superimposing. So I'll come over to this point and do CO, enter. No, sorry, I'll come and click on this. Click on this, right click on select similar. Superimpose is the process whereby we copy the whole column to this first floor and check whether any of the column is causing obstruction. So I'll come over and do, okay, I've done CO. I want to copy from step. Whenever you are doing superimposing, please, okay, CO, enter. Whenever you are doing superimposing, please copy from the staircase, because the staircase will be the same even at first floor, second floor, and third floor. So copy from the staircase. So I'll come over to this point and I'll paste it here. I'll zoom out. So if you see, okay, yeah, thank God, that means we don't have much work to do since there is no column causing obstruction. As soon as I'm having a column here, and that means that column will be causing obstruction. And to the first design that we did, that's in this YouTube channel, the design we did, a column was here and it was causing obstruction. So if you want to learn how to go about that one, you can go and watch that video. The title is complete ProtaStructure tutorial 101 ultimate beginners guide. So you can go and learn, you can go and watch the video so you see how to go about it and also how to model it in ProtaStructure. So right now I'm not having any column causing obstruction, so this is okay. I'm through with my superimposing. That means I can go with this drawing is okay. I'm through with my general arrangement drawing. So next thing now is to save this as a DSF file, but don't forget you can equally get the CAD file and practice. So if you see, we have done everything. Look at it, this is a 3-story building. Look at it, this is the first floor, second floor, and this is the last floor. Yeah, we have done the structural detailing and of everything. So if you get the CAD file of this architectural plan, you also get this structural detail. So in case once you are doing your design and you encounter any problem or face any challenge doing your detailing, you can always come here and reference it to understand whatever you are doing. So we have done it here, so to make it easy for you. So right now, what I'll do now, and also don't forget, if you are finding this video helpful, please, it won't take you anything to just click on the like button. Just click on the right button. It will even take you 10 seconds. And also share this video. Yes, share this video. Sharing this video now will not really take you up to 10 seconds. Just go to the sharing and share it maybe in your class group or in your work group, any of them. So right now, to save this, I'll save it at the origin, because ProtaStructure recognize file saved at origin. Like you easily trace your file or your drawing once you save it at origin in ProtaStructure. So for that reason, I'll save this in my origin. And also, not just that I'll save this in my origin, I'll save it in DSF file. So okay, so to save it, before I'll save it in my origin, I'll come and check which of this grid line are we not making use of. So if you check this grid line, I'm not making use of this grid line. Yeah, I'm not also making use of this grid line. So at this point, you delete the grid line you are not making use of. So this is just the grid I'm not making use of. I'll just type E, enter. Then to locate my origin, I'll type L, enter, 0, 0. So this is, I'll click on enter. So if you zoom out, wait. So this is, I've seen my origin. So this, look at my origin here. This is my origin. So I'll come over to this point and then do CO, enter. So I'll copy this drawing from this point and remove my auto key by clicking on Control F8 and locate my origin. So this is my origin. So at this point, I will do E, enter, delete this line. If you are finding this video helpful, please don't keep it to yourself. You can do well to share it. If you're a student, share the link of this video in your class group. If you're a practicing engineer, you can also share the link of this video in your work group. You can do it right now. In fact, it won't even take you up to 10 seconds to do it. Just pause this video, click the share link, and then send it to your class group or your work group so that more people will get to see this and they will also learn alongside this one. So this drawing now is now in my origin. Then to save it, you highlight it. Once you highlight it, you type W. W stands for web block. W, enter, which is web block. Then I'll come over to this point, change this insert unit to millimeter. Yeah, make it to be millimeter. Then I'll come and click on this 3 dot. I'll click on it. Once I click on it, I would like to save it on my desktop. So I would like to save it on my desktop, and you make sure that this is DSF file, because ProtaStructure only recognize DSF file. So I'll click on it. Then I'll now change the name. I would like to use the name three-story YouTube. Yeah, because this is a YouTube video and this is a three-story residential building. So I like to use three-story YouTube. So this is a three-story YouTube. And after everything, I'll then come and click on what? Save. And then come and click on what? Click on OK. Then at this point, if I want to see my file, I will just minimize. So look at it here, three-story YouTube. So I will just double click on this. I'll double click on it. I'll double click on this. So look at it here. Hope you are seeing it. But if you see it like this, don't panic. You just type to bring out the line width. You just type line width. Just type line width. Yeah, this is line width. You now come to this point and click on display line width. Once you click on it, then click on OK. Yeah, you start seeing your line width. So this is it. So now we have saved it in a DSL file, and this is what we'll be exporting to ProtaStructure. So right now we have come to the end of this video. Don't forget, you can get the CAD file and practice on your own. Practice makes what? Perfect. Practice makes perfect. Get the CAD file and practice on your own, because the more you practice, the more you learn. If you watch 100 videos without even practicing anything, and someone else watches only 10 videos and just practice that 10, that person will be far better than you once it comes to structural design, because it's not all about washing. You need to take action and practice, so it will become part of you. So get the CAD file. The link is in the description below, and practice on your own.